Welcome. I have been at PlayStation now for about 2.5 years, and this is an update on our journey. And maybe I'll get a read from the audience first. Who among you have deployed a machine learning model into production? Awesome. And who of you consider yourself ML engineers? Yeah. I am reaching out there because at the end I kind of describe the work that we're bucketing for an ML engineer, we're advertising for an ML engineer, and I keep trying to formulate a model for the kind of work that involves. So I'll share that with you momentarily. What I mean first by this low latency, so under 20 milliseconds, faster than the eye blinks, and my near real time is that you've done something and within 5 seconds we can now react to it. And large scale meaning tens of thousands of requests per second. That's because we're PlayStation, where we push the boundaries of play. We want to be the best place to play. And now we can do so much with data. We started kind of humbly in 1994 with PlayStation 1. And that was the third most successful console of all time. Just last year, we sent out the Classic, and I have one to give away. But I was trying to find ways to do this fairly. One is, do any of you have a birthday in the remainder of the year? If you want a PlayStation, then raise your hands. So I see one hand, two hands. Okay, so there's, three. How about, let's be a little fair, in November? Okay, we have a winner. So after the talk, come on over and get your PlayStation Classic. And that was the third most successful console. The second most is the PS4. We have just broken through the number of sales there, so on a good track. We've got a nice precedent. We've got lots of data now, and we have this ambition of continuing. We now have virtual reality headsets and a subscription service where not only do we want to sell you now, because now you're a subscriber, we want to recommend things that you can play because it's all there for you. Also, we want to prepare for the PlayStation 5. Which is going to have a solid state drive. It's going to have 8K haptic feedback, and it's going to be backward compatible, so right away you're going to get all that gaming experience from the PlayStation 4. So this is sort of really what we're preparing for. But for now, we're focusing on the PS4. This is what I can share with you, and that's the low latency experiences that we can deliver that are personalized, kind of very relevant. I'll start with the kind of clear one, games, recommend games for people, maybe also because your friends are playing them. We have a rich social experience inside there. Within all those 100 million people, they often play with their buddies. And it starts with a person. So we started a year and a half ago to build a profile of our customer. And one that is non-identifying, so no names, no addresses. So my team can work with this data because it's non-identifying. It's how you've been playing with a random key set for the user that we can then send to the console. We also want to take care of the context. So is it daytime? Are you on the phone? We have a mobile experience. We have a web experience. We have the console experience. And from that, be able to submit from the tens of thousands of games that we have in a decreasing order, pass it through a model, get the scores, and all in under 20 milliseconds, 50,000 times per second for all the users that are on the network worldwide. Certainly, if another person comes along in the same context, they should get their own personalized scores that are most relevant. Relevant is important that we define what that is. We work with the business. In some cases, it's buy, but actually we make it even intended to be more interesting that you buy and you play. We don't just want to recommend you stuff that you throw away. We want you to play, so we want it really engaging. Also, we want to take care of the context. Let's say it's a different time of day, you moved temporarily, that should change. Also, you've turned off personalization. We can still at least personalize for, basically the time of day, what country you're in. Or one other way that this is important is, let's say you're a brand new user, there's very little information about you, we need to support that. I'm setting it up for giving you like a taste of the kind of ML that we do, but there's many others, but this at least makes it concrete for you. So for this, we've built our own internal relevance scoring platform, enterprise-wide. So the intention is that any engineer can come along and use this score, this platform to deliver their own scores, self-service. On top of it, though, or below it to support it, we've developed 3 other platforms. I'll talk about these 2 a little more. Certainly an ML platform, we've built our own. We're on AWS, on the cloud. So we're leveraging some of that componentry there. I'll tell you more about it. All over, and then this larger framework with online experimentation, our data lakes platform, our data ocean, and the ingestion of data into that ocean. So this ML pipeline is intended to help any ML engineer, and maybe even data engineers, to also deploy data assets offline and online. So not just kind of in a batch mode, but also in the real-time ability to retrain. There's plenty of challenges, ... There's how do you facilitate the deployment of these, both batch and streamed. As the data comes in, we want that 5-second latency on the updates of information. How to create these machine learning data sets. Machine learning data sets for training have this interesting property. You need to do time travel. So you want the information from the past to predict the future. So you need to have this facility to quickly talk about the past versions of the data and current versions of the data so you can have your target be in the future. There's no information leakage. And plenty of monitoring. This is a kind of high-level design. We keep evolving it, so this was now already changed since this one, but you can see the role of S3, Jenkins, GitHub to commit the code and run the inference code on Kubernetes for prediction. So this is the ML platform. Then the customer and item intelligence platform. This is an abstraction based on the description of data that we've done in the processing. So we want a nice way, clean way, predictable way to talk about the user, the customer, and these items that we need to predict. So very large. Everything's going to be in S3 in Parquet files, but also the information that we need real time, the information that's going to be read within 1 or 2 milliseconds to run to the model, that right now we're using Aerospike. Also, what I don't show here is we're using either Spark Streaming or soon Flink to update those values. Plenty of lessons there for us about how to keep this information fresh, and also some governance around it so that we can know which is the right version of an attribute. We have different teams creating the term age, and they have many of them. We want one. So this is all that kind of information that platform needs to support. There isn't really anything out of the shelf that just delivers this feature store for these 2 entities, so we've built it ourselves. Now, this was a relevance platform that I started with, so I'll just mention some of the challenges to regularly score. So 100 million active users. We don't know who's going to turn up next minute, so we would have to rescore everybody. We started out that way where we scored everybody every night, but that gave us fairly slow-moving predictions, and also wasted a lot of resources. So now we're on demand. Since May, now the person comes and we get this information for them. How to personalize less active users. So I'm going to focus on this one. This is one of the important challenges that we encountered right away. So in these recommender systems, there's a long tail of users that don't really have a lot of interaction. They show up every other month or every 2 weeks. They have fairly minimal engagement, and a lot of items that are maybe falling out of favor, but they still have some life. Solutions like collaborative filtering. Who's worked with collaborative filtering here? A few of you. Who are really great at the head and trunk of this distribution, matrix factorization, or even neural network methods that only use interaction data. But we really also wanted to be able to have a good experience for these people and for these items. And so how to do that? We made use of our rich profile. So based on your tenure, how active you've been in the last year, all that information in the customer profile can now be used by our algorithms because we're using those features, we're storing those in Aerospike so that the neural network model or the random forest model can make use of that information. Same with the items. We can see how long the item has been around, what genre is the item. So even if there's not a lot of activity right now, it can still use those other bits of information. So our customer and item intelligence platform is really critical for delivering the intelligence we found. That helped us address one of the challenges to build this relevance scoring. I won't go over all these other challenges to deliver the platform. I can talk with you offline about them. What I wanted to change topics to is the actual engineering. On these three components, the data ocean, the A/B testing framework, and our ML platform. So I'll move these around a little bit. And these are the components that my engineers often work with most for doing development, for automating their jobs, so creating the jobs, automating them, and then monitoring them, alerting on them. Get that call in the weekend, somehow our inference model didn't deploy properly and it's down. Has to be part of our tooling. Then, these are the key tasks that differentiate the kind of ML engineer. We need to be able to explore data, need to be able to process data, to extract the valuable information in a predictable manner, doing the feature generation, training data, deploying the inference, and then doing A/B tests. I'll go through these as well to characterize how we do it and why we do it. So identify data sources. There's this data ocean, has a ton of data. We need tooling to be able to find it. Nothing too sophisticated here. Allocation is what we use. We use Presto SQL to be able to do aggregations. So this is typical data science work, analyzing data. Now we get into some of the challenge of doing something every day in a very repeatable way, or every hour, or even online. We need to extract join, so we need to, for example, parse JSON to extract the values that we need from that object, and then clean them, join them with some maybe product catalog to make them really useful. Part K is 3, or maybe, and here, by the way, our data engineers often do use Scala with Spark to do this work. I don't mention it here, but for the online version of them, we Spark Streaming or Flink to push the data that we consume through Kafka. So our challenges are how to do unit and acceptance testing, and there isn't kind of a formula for describing, for putting the specification of these data assets and these transformations that we receive. So we're working through that. There's not much of a tooling component there, but more of the process. So if you have any suggestions, I'd welcome them. How to detect job failures that are actionable versus ones that are going to retry. Data quality monitoring continues to be a challenge, and tuning for now the Spark jobs. So this is one of the tasks, important tasks that our ML engineers do. We are for some of them we're referring them to a data engineering team, but often we're the first people who do this. Now comes the feature generation. So here, again, we use Spark. Here, it's mostly the data scientists kind of so they prefer to use PySpark to do this. But we do have this component of feature stored library, and again, pushing this into Aerospike and into Flink. Job error handling is an important challenge because if the feature doesn't get updated, now we're not giving the customer the recommendations that are really relevant to them. Or maybe there's a rule around it. Did they buy this game recently? Oh, we can't tell you because we had a job failure. It's 24 hours late. And staging environment, so we develop this code in staging, but our staging environment doesn't have a full copy of our data ocean or data lakes. That's quite challenging, that it's hard to predict the behavior when we go from staging into production. And it's pretty difficult to always get these snapshots of an entire data ocean or data lake environment. Training data now this is what most of you maybe know for as machine learning and data science. I'll go through this quickly. By Spark, the ML libraries of Spark are very handy. We're also experimented with Keras and TensorFlow. They haven't quite found a way to beat the Spark ML processes yet, but we're working at it. And one of the challenges here is that it's a very notebooky environment, moving from doing this development in notebook world to then committing that code and having that stability in environments is still an area where we're working through. So I'd love to hear from you any approaches you've made to solve that. Finally, we have a model. Every week it's going to be retrained, or actually, yeah, every day or every week. We're still figuring out what the value is between doing it every refreshing daily or weekly. And here, the data comes from Aerospike. The code itself for inference is in Scala. We've serialized the models, read them into our Kubernetes Docker environment. Some of the other techniques that we need to familiarize ourselves with is gRPC and protobuf for communication between systems when we deliver the recommendations. Having a realistic test data is difficult. Shadow testing, monitoring the output. So we make predictions, 15,000 times a second, and we found that it's important to monitor where those predictions are trending. If all of a sudden they head south or north, we don't know why, but that's unexpected, so we need to put an alarm on that. Finally, A/B testing. This is not too much tooling involved here, just statistical hypothesis testing skills. In development, YAML, Jenkins, GitHub, as you develop, to create these libraries, we try to put some automation in here with libraries, and with operations, with Prometheus, Grafana, Sensu, Xmatters, because we need to be alerted when these systems go down because they're driving customer experiences. And all of this to say that these are all the tasks that our ML engineers do. One of the things that, we quickly can recognize from this is that the ones I've highlighted here, these are the kind of traditional data science-y skills. And the others are more software engineering skills. So how do we combine those two? One way we've done this is by holding an ML University training within SIE to discover which software engineers can also perform those machine learning tasks, those data science tasks. And we've had really good success with it. Here's a couple of our classes. We're off software engineers that are now ML engineers because we discovered that they already had latent talent in doing these tasks here. We trained them up on doing these tasks, and now they're part of the ML team. And so I recommend, for your organizations to discover the engineers inside the organization that can maybe aspire to and actually have a skill in ML as well. So that is our journey so far, a review of all the sort of methods, how we've decomposed the problem, and some of the technologies that we're using along the way. More to come, but for now, that's all I have for you. Thank you.
Alrighty, and we've got time for a few questions. I will pass this microphone around.
Hi, you
Great talk. You mentioned A/B testing
Sure.
at the end when you're serving models. Have you also thought about moving forward on expanding to, say, a contextual bandit? Because you already had some contextual information about each user.
Sure. Yeah, it is on our roadmap for our online environment testing framework to have multi-arm bandits, contextual bandits, because the richness of the information doesn't. Well, an A/B test is just a fairly slow way to try to identify that. So it's, for now, we're still at A/B test work. But yeah, it's on the way.
Are there any other questions?
Can you tell us a little bit about what you do to get some of that personalization in the tail? Because that can be pretty darn tricky to get interesting features and recommendations out in the tail.
Sure. So as I showed, that there's a long tail of many, many users, many, many items that don't have a ton of interaction. And that's because we're focused on a specific experience. Let's say we're at the store, and there's not, with a game, you're going to buy a game every few months. It's very slow-moving information. But what they do is they interact in other experiences. They play. They send messages to their friends. They like posts. So all that information, it gets summarized in their profile. So all this other behavior around them is now condensed. We're not quite at using an embedding space to condense that information in some obtuse way. We literally have feature engineering of their most used other experiences, how much they play, and how much they interact socially. Is an example of how we can then characterize the person to say, aha, you're more of a sports person over a shooter kind of video game.
Any other questions?
Following that, this anytime recommendation happens, there's this, like, you can just get into a funnel and closed off. Is there any metric or interesting thing that takes like a linear combination of genres into account for that recommendation, like the epsilon in multi-arm bandit, for example?
Not right now, in part because we want to be very general in our description of the person so that it can be applied in so many different experiences that we don't want to tailor the information that we store for the specific engagement that the person has. So one day we may say, there's additional value in actually using what they do in the store specifically for them, and then testing with the multi-arm bandit to see what bits of information are the most helpful. So not for now.
Any more questions?
Well, don't forget your classic, and thank you.